Good morning, this is your Stats Sensei, Mr. Sensei, and this is Death Packet Regression and chi-squared, and we'll be focusing on regression problems 1 through 10. So researchers studying koi fish collected data on three variables, A, B, and C. The following residual plot shows the residual for a model for predicting each variable from the age of fish. And the question is, a conclusion that a linear model between the variable and age is appropriate is supported by which plot or plots? Well, if it's a residual plot, we need random, which means we should not be able to tell where the next data point is. Well, this one's random, so this one would qualify. This has a pattern, so B is bad. C has a pattern, so it's also bad. So the only one that works is A. So the plot for variable A only is our answer choice for that one. All right, moving on to number 2. We're trying to. All right, the following scatter plot displays the data collected on mass in grams and the age in days for a sample of chameleon eggs. Which of the following is the best description between the mass and the age of the chameleon age? Well, first off, I see a curve. But I also go, well, if I had to draw a straight line, what would that look like? My straight line would something like this. And the only reason I draw a straight line is sometimes it kind of gives me a hint as to what's going on. All right. So that probably be something along those lines. Maybe it needs to move a little bit, but that's close. All right. So which of the following is the best description? The association is negative and linear. First off, it has a curve. And then the other thing is this is definitely positive. So this one's completely wrong. The association is positive and linear. I do agree it's positive, but it definitely has a curve. All right. So that's not good. There's no association. And I go, no, there's clearly an association because it follows this curve. The association is positive, yes, and it's nonlinear. So I happen to like this answer as the best choice. I like D for number 2. Number 3, based on the plot, is it reasonable to conclude that a linear model is appropriate? And I'm going to sit there and go, yeah, it looks pretty random. All right. And if the residual plot is random, then a linear model, it tends to be appropriate. Yes, because the plot shows no apparent pattern. So that's my best choice. I like that. All right. Let me talk about this. If it shows less variation, that's a problem. That's failing homoscedasticity. All right. We need to have no pattern of variation. Variation shouldn't change. And yes, becomes the sum of the residuals is close to 0. Matter of fact, the sum of the residuals is 0, and that'll always be. So that's not the reason. The reason is because it's random. Okay. Number 4. Biologists conducted a study to investigate the flying velocity of mosquitoes both before and after feeding. The following scatter plot shows the velocity after feeding in centimeters per second and the proportional increase in weight after feeding. Before, for example, 0.5 indicates a 50. All right, so what is unusual about point M? Well, this is my velocity, and it appears that this guy is moving very, very fast. All right, very, very fast relative to the others. Because the others, the next highest one is at, it looks like about 13, 12 and a half or 13. It gained the least weight after feeding. No, I'm going to say this one gained the least, so this M's not the least. It gained the most weight. No, the most weight, proportional weight, is up here. So no, that's not it. It represents a mosquito that flew very fast after feeding relative to all the other mosquitoes. And I'm going, yeah, this mosquito moved very fast. I like C for number 4. All right, number 5. The following scatter plot shows the company's monthly sales in thousands of dollars versus monthly advertising spent. All right. So here we have sales, here's we have dollars spent. Which of the following is most likely a high leverage point? All right, a high leverage point means that in the X direction, we're a long way off. All right, we're a long way from the other data points. So in the X direction, I'm going to say this value right here is one that's probably the farthest away. So 5.1 to 105 would be number five. I like A for that. If and if I were drawing my regression line, it would look something like that. And the reason it's called a leverage point is that point has a lot of power on swinging it. This point and this point, and I'm going to call them A and B. A and B are likely outliers because they are a long way from the prediction. All right, they're a long way from the regression line. They have a great residual. Having a big residual, probably an outlier. 6, a marketing consultant created a linear regression model to predict the number of units sold by a client based on the amount of money spent on marketing by the client. Which of the following is the best graphic to evaluate the appropriateness of a model? Appropriateness of model, we're wanting to know whether or not our data points are completely random, and we do that through a residual plot. So 6 should be C. All right. Number 7, the scatter plot below displays the relationship between the percent change in the population of wolves and moose density in number of moose per square kilometer over a 19-year period in a certain region. Notice that the association is negative. So, all right, as the moose increase, the wolf seems to decrease. So it looks like moose, as it goes up, wolf goes down. All right, because the wolves are going this way and the moose are going up. Also, I notice there's greater variation. All right. Suppose the variables on a scatter plot were reverse of the moose density was the response variable on the vertical axis and the percent change in wolf population was the explanatory variable. Which of the following would be true? All right. If we did that, if they switch, it would still be the same situation. Moose would be up high, and when the moose are up high, uh, it's the opposite direction. So when that happens, direction and strength of association do not change. So swapping the variables, and this is really important to know, swapping the variables as far as explanatory and response will not change the relationship. So the relationship would still be negative, all right, would still be negative, and the strengths would be the same. Suppose that scatter plot of log x and log y show a strong positive correlation close to 1. Hey, this is great. So we know that log x and log y work. Which of the following is true? The variables x and y will also have a correlation close to 1. No, that's not true because a log is not the same as this. All right, because the logs have a different distribution. So they have different distributions. So log x and log y, if they're highly correlated, x and y will not be on their own, only if you put the log function to them. A scatter plot of variables x and y will show a strong nonlinear pattern. That is true. They will show a logarithmic pattern. All right. So 8B, for 8, I like B. The reason we know this is because the log was appropriate. If the log was appropriate, that means they have a nonlinear pattern. And a line would not be appropriate. Number 9, a new town was incorporated in 1960. The size of the town's population was recorded every 5 years after 1960 using the variables x for the number of years since 1960 and y for the population. 3 models were created. Predicts y from x, predicts the natural log of y from x, and predicts a natural log y from natural log x. The following graphs show the residual plots. Okay, so we're looking for a residual plot that is random. Well, in this one, not random. There's a pattern. All right. Pattern. So this is not good. All right. This one, pretty random. I'm liking it. So model 2 looks like it's working. All right. Model 3 definitely has a pattern. All right. If it has a pattern, that's not appropriate. So residual plot for model 2 appears to be appropriate, which is a natural log of y from x. So when we're looking at our answer choices for number 9, residual plot 2 is the most appropriate model of the 3 models. That is correct. And the reason why is it's the only one that was reasonably random. So that looks pretty good. I wish I had another point here to balance that one out, but it's reasonably random. All right, number 10. In the following scatter plot shows the ages and years of 12 of the wealthiest people in the world, along with their net worth in billions. Man, that's a lot of money. The data point at age 83 is labeled Q. Okay. Suppose Q is removed from the data set, which of the following is likely not affected by the removal. So let's see what we think is going to happen as it is. Right now, the way it looks, with Q being there, I'm thinking my regression line probably needs to look like this if Q is there, because I have to balance Q out. Maybe it should be even a little bit lower. Maybe it should be down there. But matter of fact, I'm going to redraw this. I'm going to say this line right here, this one includes Q. So if Q's included, I kind of need to include this. So this includes Q. All right. But if I take Q out, I'm going to do this in pencil. All right. Because Q's gone. I'm going to say, okay, the pencil is no Q. All right. So what happened here? Which of the following is not likely not affected? Well, the correlation coefficient is going to be affected because I don't have this great giant residual. So it's definitely going to be affected. The sign of the slope. Ooh, well, this had a positive slope and this had a positive slope. So that looks like that's my answer. Let's keep going, but that looks pretty good. The value of the slope. Now the slope definitely changed. It became steeper. So it definitely increased. So that changed. The sum of the squares of the residuals. Well, if I get rid of this big residual, the sum of the squares will change. And then the net worth intercept, that's going to change slightly. It will change, not a whole lot, but it will change. So the only thing that won't change is it's still going to remain positive. All right. I hope that helped. Look forward to seeing you on the next one. Thank you.